Hi, my name is Benisha Rangar, and our group will be answering the challenges that were given on day 3 of the Mars mission. We will also address the hazardous health concerns that we face on our mission to colonize on Mars. Together, our team has made colonizing on Mars a safe and reachable goal.
Hi, my name is Harleen Gill. I'm the humanitarian, and I'm going to walk you through the process of an appendectomy. So, first, what is an appendix? The appendix is a small pouch like organ which connects the large intestine to the small intestine and is located in the lower right abdomen. It does not serve a large impact on the body, which is why it is easily removable due to little impact. Now, what is an appendectomy? An appendectomy is a major abdominal procedure that is performed when an infection has caused the appendix to become inflamed or swollen. This condition is known as appendicitis. The infection may occur when the opening of the appendix becomes clogged with bacteria and stool. This causes your appendix to become swollen and inflamed. This infection must be resolved immediately because the patient suffers the risk of the appendix rupturing and then further sending the harmful bacteria and fecal particles deeper into your abdomen. Now I'm going to walk you through a step-by-step procedure of removing the appendix. 1. A small incision will be made in your lower right area of your stomach. Second, your abdominal muscles will be moved to the side, and then further incision in the abdomen will follow. Third, the appendix will be cut off from both the large and small intestine, and both the intestines will be tied off. 4, the appendix is sealed with stitches and then finally removed. And then there's an additional fifth step, which happens to be if your appendix bursts before or during the procedure. So what will happen will be the surgeon will flood the area with a saline solution to flush out any bacteria from fostering in the area. Thank you.
Hi, I'm Daetwyler, and I'm the hacker of the group. Obstacle 1, appendix removal in space. Before sending our astronauts into space, we would adapt similar precautions to the ones that NASA has put in place to minimize risks. As it turns out, having unnecessary organs removed, such as the appendix, is a part of their precautionary measures. So this situation of someone needing to perform an appendectomy in space is no longer a danger. In the case of a mishap in our pre-liftoff procedure, we have devised a backup plan to perform life-saving surgeries even when faced with difficult circumstances brought by space, like the absence of gravity. Our appendix removal procedure. In the case of our captain's unfortunate development of appendicitis, immediate action must be taken to remove the appendix. Performing a surgery to this scale is simply not possible when there isn't a gravitational force pulling the blood in place in the body. The patient would die almost immediately from blood loss. To tackle this issue, we have to create an artificial gravity. We plan to achieve this by using centripetal force created by rotating our spacecraft around a center point to create a force on the outer walls that would equal to the force of gravity. Although in order for that to be a possibility, our spacecraft would need to be circular, unlike the heavy lift rocket we chose in our last challenge. The ship would instead have to be adapted to the design provided on the screen. So here you can see a large ring would rotate around the center to create a force on the outside walls. With our main issue, gravity, being resolved, performing the surgery will be much easier. There will be a team of 2 top-tier doctors amongst our space crew who will be intensely trained and qualified for these kinds of highly stressful situations. We will also provide them with many instructional surgical textbooks in the case of uncertainty with a particular procedure. We will also magnetize their tools to help them keep in place.
Addressing obstacle number 2, our solution to the radiation on Mars. Due to the lack of magnetosphere and atmosphere on Mars, there is high levels of radiation. The ionizing radiation is composed of alpha, beta, and gamma rays. The alpha rays can be blocked by a piece of paper, the beta rays can be blocked by dead skin, and gamma and neutron rays goes through the body, damaging the DNA. Therefore, we have created a protection from these radiations through our establishment on Mars. This greenhouse dome and living space will give us full protection from any radiation. The greenhouse dome covers the whole establishment on the outside. The greenhouse dome is composed of CO2 ice, water, and glass. The CO2 ice can absorb infrared radiation and will also help trap the heat inside the dome. However, CO2 freezing point is negative 78 degrees, which means that it will sublimate in the temperature of the Medusa phosphate formation. To overcome this problem, we will need to keep the CO2 contained in the glass in case it turns into gas. The glass will also allow sunlight and sun rays in for plants to do photosynthesis and have source of solar rays for the solar panels. The dome will protect the solar panels from dust storms as well. Also, 5 meters of Martian soil is equivalent to the protection of Earth's atmosphere. So on our life dome, we have 5 feet of Martian soil because 5 meters is a little bit unreasonable. We also have human waste bags, which Benisha will talk about later on in the presentation, which also helps us protect from radiation. Our lead wall will protect us from other rays like beta rays and alpha rays. Thank you.
Hi, I'm Anna Shields, and I'm the hound for our group. So as you can see in the bottom diagram, it's kind of like a water cycle where we move the cold water up from treatment so that it can run down. Here, wait, I've got a diagram here. We move the cold water up from treatment through a pipe so that it can run down the sides of our dome, which is kind of like a flatter shape so that the water will run down slower. And also the lesser gravity on Mars will help the water run down slower and we want the water to run down slower so that it can get heated up by the sun longer. So the warm water runs down the pipes, runs down the glass and is collected into pipes. And then the pipes run under the floors to warm them. And it won't be like super hot, but it's better than freezing. And then are collected for use. Gray water, as you can see in this right image here, water from sinks and showers is gray water, and we'll have to use organic soaps. But the gray water will go to the hydroponic gardening lake. And then brown water will be used brown water will be sent for treatment, and then water from the lake is also brown water. And then that's that. And then this is it's a little architectural sketch of our dome. And so I have it here too, actually, but we have in the top right corner, we have living space and bathrooms because you're not going to want to walk that far to pee in the middle of the night. Then we have waste management, a lounge, a cafeteria, the kitchen, clinic with a closed off surgery for like sterilization purposes, the school, storage, science lab, water treatment, exercise area, manufacturing for clothing and other things like hats and shoes. And then in the center, which is 494.211 acres, on the left, we have solar panels, which will be plenty to power our entire dome, and leftover energy will be stored in batteries. At the bottom, we have space for our livestock, which will be sheep and chickens. And then on the right, we have our hydroponic gardening lake, which will be vertical hydroponic gardening. And it's a whole lake actually filled with fish. And we have a walkway through the center, and there's a little drawing of the walkway just for reference. And I drew a little boat in there, which is not to scale because that would be a huge boat. And then, so hydroponic gardening. What is hydroponic gardening? It's when you take, hydroponic gardening is when you grow plants in water. Vertical hydroponic gardening is when you take a post, like a plastic post, and you put plants in it at a 45-degree angle, and then you can run the water through so that it drips slowly and the plants get all the nutrients that they need because the water has to be filled with nutrients for this to work. It is, as studies have shown, 99% more productive and successful than regular farming, and therefore also requires less space. For our hydroponic garden, we will have, so it'll be like, there will be pillars to support each little vertical garden thing, and then it'll be surrounded by a mesh cage to keep the fish out. The fish are in there for like eating and also to like fertilize and give nutrients to the water so that the plants can grow better. And then at the bottom of each, there is a pump to send the water up to water the plants. To harvest the plants, you will have to take a boat around, and also harvesting plants, that'll have to happen outside. Because it has to happen outside, that means that the farmers have to leave the safety of the radiation covered rooms, which is, it's not the greatest, but we have come up with alternate solutions. Like, for instance, glowing algae. At MIT, they did discover a way to infuse plants with bioluminescent properties similar to fireflies. And so if we have bioluminescent infused algae in our lake, it'll allow for 4 hours of extra light time without all of the extra radiation from the sun for our farmers to work by. So if they do 4 hours in the dark and 4 hours in the sun, it'll be significantly less radiation exposure than if we do all day in the sun. Also, the water in the dome ceiling, in our little dome ceiling there, will protect from that other radiation. I think it was called, no, I can't remember, but Pankti talked about it. So yeah, this is what our dome would look like. We have our living areas here, our hydroponic gardening lake, and our solar panels. And yeah, it'll be great.
Hi, my name is Benisha, and I'm the helper of this group. And today I'll be talking about the health risks on Mars. There are many health risks associated with going to Mars, such as radiation, human waste, bone density, and muscle atrophy. Some of the solutions we've come up with for radiation and human waste are, the solution to the intense radiation on Mars lies within our own waste. We will be using bags filled with food, water, and both liquid and solid human waste to protect against harmful radiations. Lining the walls of a spacecraft or our dome with layers of these bags creates a 40-centimeter thick liquid shield. All of the bags will initially be filled with drinking water. The crew would then fill other bags with waste during the trip to Mars and swap them out for the now empty water bags. This is a new approach to protect against radiation. However, it has proven to be successful in ground-based tests. Health risks continued. Bone density. Astronauts in space lose 1% of their bone density each month. As we plan to settle on Mars, this problem needed a solution. The best way to build bone density is by doing weight-bearing exercises such as walking, jogging, lifting weights, and playing sports. For this reason, we have included a gym. We will also be increasing the amount of calcium and vitamin D in our residents' food. Biphosphonate will also be given to astronauts as it helps prevent against osteoporosis. Muscle atrophy. Muscle atrophy is when muscles waste away. It is usually caused by lack of physical activity, but in our case, it's caused by lack of gravity. Studies have showed that astronauts experience 20% loss of muscle mass on space flights lasting 5 to 11 days. The only way to minimize muscle atrophy is through intensive exercise, strength training combined with an adequate diet. Thank you. The picture on the left shows us what happens as bone density progressively gets worse. And the picture on the right is an example of the human waste bags that will be used to protect against radiation.
This is our group's Works Cited page. In our mission to colonize on Mars, our #1 priority is health and safety of all citizens. We hope you feel safe in our hands. Thank you very much.